Chapter 5, the second part of Section 3, the grouping method. I wish they would show a couple more examples about this. If you can get skillful at this grouping method, and it takes maybe some ability to group and organize some things in your head, or find a method that works for writing this down, because it can, well, obviously when you look at this example compared to the full writing out of the anti-FOIL methods, this can be very, very useful and save a lot of time. And I've seen some students just jump right into grouping. Saves a lot of times, which factoring can be very time consuming. So they have a little more time to work on some other things. So what they're going to go through here again is, let's go back and let's look at what happens when we multiply again. And they're going to really, in the grouping method, is saying, hey, maybe I can look at my trinomial in a way that I break up this middle term into an addition and look for some ways to find a common binomial that I can factor out of two groups, is one way to say that. And so they go through this again. They say, well, you take first times first, you get 2x times 3x in this case. And back here you get last times last, the L. Then you have outer times outer, 2x times 4, and inner times inner of 5 times 3x. Well, if I kind of leave it in that mode, if I leave it all factored, right, and I can change orders of my factors in a sense here. They change this multiplication order. Remember, 2x is just 2 times x, 3x, and so on. Well, with the commutative property, I can change the order of that multiplication, and I can change the order of this multiplication. And what they're doing here is looking for possibly some ways to have a common grouping to do that. And let's look at this again. So they change the order of this to be 2 times 4x rather than 2x times 4, right? And 5 times 3x. So they take out this in a way that hopefully you can recognize that I have a grouping that happens in here of pulling out a common factor of 3x plus 4. Notice that in this case, and they don't show this very well here, is, and we're going to look at it again, here I got 5 times 3x, and here I have 5 times 4. So I could factor that out as 5 times the quantity 3x plus 4. And why that's important is, here's my 3x and here's my 4. Okay? And we'll go through that again. So reversing these steps, if you can see that in a way that, say, I can look at my factors, can I rearrange this, make sure you use, you can't mix the order of multiplication with addition, you're back into distributive property. And another key thing that students that I see are successful at this method are very solid on how their properties work, because we're going to use that to every advantage we can when we do this, and so on. Okay? So they keep going. It says, note, reversing the step shows that 6x squared plus 23x plus 20 is the same as 6x squared plus 8x plus 15x plus 20. And in this case, we note that the numbers that add to b, in this case 2 times 4 and 5 times 3, also multiply to the AC portion of that, in this case 2 times 3 times 5 times 4, right? So we can factor some things looking at that, and I'm going to take us through a couple examples again. And here's some steps basically to look at. It says always, again, factor out the largest common factor. Then 2, multiply the leading coefficient a and the constant c, that's the last term. Okay, and find a pair of factors of AC whose sum is b. We can rewrite the middle term bx as a sum of the or difference using the factors found in step 3. And then we can factor by grouping if this works, and include any common factor in our step when we come back. So let's look at example 6 here in this case. So first we note there's no common factor. Again, we look for common factors. And then if we go 3 times negative 8, we get a negative 24. And if we look for factorizations of negative 4, whose sum of the factors in that coefficient, for the middle term, so in other words, when we get 2 and negative 12, we get a negative 10. Hey, that's the pairs of factors, right, that give us this. First they look at this product right here. In other words, it's like last times last, right? I get negative 24. And then I want to get factors of that will add up to my middle term. Okay? So normally they say we'd stop at that point, but they list them all to make sure that you kind of understand the pattern. You may not choose this order, so you won't find it in exactly the same step. So when we find that, we know that we can get factors of that give you that negative 24. We can choose the inner and outer terms based on those factors that add up to negative 10, right? So we get 2x and negative 12x. Okay? So what they do, that gives us the place or how to write that trinomial into something that looks like it has 4 terms, but really it has 2 like terms here. And when you do this, I can say, hey, this really has a common factor between this part and this part, because I can group this now because it's all addition. Remember, this is really plus negative 12x. And it gives me the ability to group and pull out a common factor for these 2 groups that I'm going to make. So I group this 3x squared plus 2x. Well, they have a common factor of x in here, so I can factor that one. And this one is negative 12x plus negative 8. Well, I can factor out a negative 4, and I get 3x plus 2. So how grabbing those middle terms in the correct way is splitting those. You know, it still adds up. You know, it adds up to negative 10x, which is our original middle term. Gives me the ability to use this grouping as a factoring strategy. Okay? So then check, always check, right? And make sure you don't forget some common like term we took out at the beginning. In this case, we didn't have anything. So I multiply back, and what do I get? Yeah, I get my original trinomial. Let's look at example 7 here and go through this again. And I think I'll well, let's go through this. Let's actually do an example here with going through the steps again. Okay, here we go. Here's an example like this. First thing, what do? It says we select the correct choice below and fill in that and so on. If I could factor all this in my head, I would just write down the factorization here, but I don't know how many years I've been doing this. I really doubt that I'll get to that point. So let's go through the steps here with this. Help me solve it. Okay. It says factor completely if the polynomial is prime. State this, which again, prime means that it has two factors, one in it. So, and in this case, definitely does not have that. So the first strategy says note that all the terms have a common factor. We want the largest positive common factor is equal to what? Now, the other thing too you may want to do is write this in descending order, which is I'd put this as 4a squared plus 16a to the 7th plus 15a to the 6th. I think if you do that, you're going to make less errors too, so you kind of have a common pattern to start from, because there are a lot of steps and it gets rather complex. But they don't talk about it here in this example. But what is my greatest common factor between all these terms here? Well, I can look at it and say, well, this is 2 times 2 times 2 times 2 is 16, and then a is a factor 7 times to make that. And I go, hey, there's 2's here. Well, 15 is 1 and 15 and 3 and 5, right, are the prime factors of that. Well, there's no 3 and 5 in either one of these. So there's no common coefficients to these terms, but there is a common a factor, right? In fact, a to the 6th is common in there. And that'd be the largest in this one. Okay, so a to the 6th power is our largest positive common factor, and I want to check that. And I was right. Okay. So now I have a new trinomial, and they still left it in this order, which is fine. I'm just saying a lot of times it's more comfortable to do the terms in descending order. But let's do that, and I think they might do that later. But if they factor out a to the 6th, they're looking at this one ends up to be 15, because I took that, it ends up to be just 15 times 1. And if I take a to the 6th times 4a squared, what do I get? I get 4a to the 8th power. So that's that term. So this one's going to be 16 a to the 1 power, or just a. Okay. And then it talks about standard form. Okay. Now we're going to deal with this trinomial. They put it into standard form where we have our highest degree term first, and it goes in descending order, right? You know, it definitely wasn't necessary to get common factors out. Remember, we're going to use this so this doesn't just go away. So here's my new trinomial, is 4a squared plus 16a plus 15. So the first part of this strategy is to say, well, what's the coefficients multiply to on my outer, right? Which would be 4 times 15. Well, that's 60, right? So we end up with 60. And then I want factors of 60, and then I'm looking at that will add up or give me a sum of this middle term, 16. Okay? So when I'm looking at these factors, I have 1 times 60, 2 times 30, 3 times 20. You know, I have a lot of factors of 60. So they just list a few here to choose from. And really what they're looking for the ones that would add up to the coefficient of this middle term, which is 16. So it'd be this one right here. Next, we're going to express the middle term then in this way. So basically all this two steps give us is, how do I split up this 16a in the middle term? Well, we can have it as 6a plus 10a. And that gives me basically the strategy to group this thing. So I can go rewrite this as 4a squared plus 6a plus 10a plus 15. Now, if I group these with the associative property, I get 4a squared plus 6a. What's the common factor of these two terms, which is 2? And then they've already done the second part for us, is 10a plus 15 is 5 times this. And again, notice that the reason we're doing this is this 2a plus 3 matches up. It's a common factor of this next new thing, so I can factor that out and end up with 2 plus, excuse me, and I need to check my answer. I would have got that wrong. That is 2a, okay? I should have went and left it that way. It's nice about when it checks this and say, oh, wrong, try it again. You don't have to start over, it just stays right there, okay? So what I can do from this is I can take this common factor of 2a plus 3, I can factor that out of this addition, right? These are really parts of an addition, part of an addition. Hey, they have a common factor of this binomial, so I can go 2a plus 3. There's my common factor between here and here, and then I need to multiply that by my parts of the factoring, right, which was 2a plus 5. And then I check my answer. Okay? And then you remember we got to multiply by that common. That first thing we did was take out the common factor of a to the 6th. So I end up with this whole thing. Here's my original polynomial. And if I multiply these three factors out, and what I would probably do this just so we can use FOIL and it's something we're a little more comfortable with, I'd probably multiply these two binomials first and then multiply by that common. You can do it any order you want, but that's probably the least amount of effort to go that direction. Okay, so I end up with that factorization of this polynomial. So that's pretty similar to going through this again. This is a very powerful way to do factoring. Look for it. You need to be careful when we're working on assignments. We went through specific methods to factor. We can end up thinking it's all going to end up that way, but when we've done a section specifically towards using some kind of strategies or methods, the assignment's going to have those in there probably for almost all of them until you get to the later parts of the assignments. But the other thing that can happen you need to remember is that things can end up prime, which means that they're not factorable. In fact, those are the ones that can take you the most time. You're going like, oh, I got to try this and I got to try that, and you can end up trying a lot of different, it ends up forcing you to try all the different possibilities of anti-FOIL, and grouping methods you're going like, it doesn't seem to work, but you're not sure. You'd probably fall back to anti-FOIL, but it really does force you to check all the methods out before you say, oh, There's just no way to factor this, so it is prime. You know, I feel bad, but I will give test questions that say we'll have trinomials that are prime, and I do understand those take time, but it's important you understand that that is a possibility. Now later on, when we go into the rest of the other skills and stuff about working with more about factoring and more about polynomials and stuff like that, then the tougher thing is, how do I get this to a place where I can use these strategies and stuff like that? So strategies to get to the next strategy become key. So good luck, and I'll talk to you soon.